Good day, everyone. My name is Nemeka. I'm a data scientist at Hamoya AI Labs, and today I'll be continuing from where I stopped last week. I'll be talking about KSAV and how to deploy TensorFlow and SKLM models on KSAV. So firstly, I would like to talk about like what KSAV is. So KSAV is like it's a whole lot of things in one place. So how will I say it? Like, previously we had to create YAML files for each of the pods we're creating. Um let me go back. So, we had to create YAML files for the deployment, for the service, and boom, we're going to have to like specify a low lot of things in each of those YAML files. If this was just a simple deployment, then where we'll have specified things like GPU, RAM, CPU for each of these things, because that's how you like build a standard system. So what KSAP offers is that instead of creating YAML files for different pods and services, you just need to create just one YAML file, and KSAV takes care of all the other things like building a service, the deployments, and everything under the hood. So KSAV is built on top of Kubernetes, like as we all know. Knative and Istio. These are like in the simple sense, they're just like networking apps, services, and it takes care of a lot of things under the hood. Then what KSAV offers you is that you can deploy different kinds of models like TensorFlow, PyTorch, sklearn, XGBoost, or NNX, TensorRT, and you can now like do some pre-processing, make predictions, post-process, you explain model explainability, and you can monitor your models, and you can do asset management. What this means is your models, you train them and you like save them into like any an SQL and a pickle format, or um a H5 format and stuff like that. So yeah, this is just what like an overview of what KSF is. And so let's just go down into the main thing. So KServe is to install KServe, you need like three things. You need kind. Okay, to install KServe standalone, like quickly on your local, you need kind. You need Kubernetes CLI, that's kubectl, and you need the bash script for installing every other thing. So, but what I'm going to go through is I'm just going to show you like we have already installed kind before previously, and we have installed kubectl. Since we've installed kubectl, we just need to install like the kserv we just need to install the kserv YAML file, if you understand that. But I'm just going to show us how the bash script is. So if I just go to my terminal and I do this. Okay, now, so this is a bash script. I don't know if some of you must have heard of bash script, and what it does is that it just helps us to run a set of commands like download the Istio service, create the namespace, create the YAML files, install Istio, then install Knative, install set manager, install KServe, and other things, and also do some cleanup. So um the that's what these that's what these that's what these is this whole YAML file does. And you can use like bash to just like install everything all at once. So that's what it does. But I just want to give like a heads up. When I tried installing the setting up KServe, I was just getting a lot of errors. And after some like debugging, I found out that this Knative version is outdated. So if you are going to run it on your end, I'll advise you to edit this and install the not the latest one because it might not be in this in the right format for this Istio version. So I think version 1.8.3 is what works for me. And if you install 1.8.3, you get it working. So that's that for the setup. And so let's go into like running our first inference. For what inference service is like is special to KSEV. Um KSEV, my network is good. So KSEV creates has his own like kind of service called inference. Let me just continue from my stop. So we're just going to create a namespace. Inference service. This is just how the YAML file of an inference service is. If you remember back when when I used just Kubernetes, we had to create two YAML files. Let me go back there and show us how to create two YAML files for this and how to create another YAML file for this. So you see that with KServe, it's just easy. You just need to create this YAML and you can deploy your models easy with that. So let me just explain. So this is how the standard YAML Kubernetes and specifies what kind of service you want to create. You can create deployment service, and this is it specifying what kind of service you want to create. It's the name of this inference service and the sklearn iris that we're giving that. And now the main part is the predictor, where the actual model is that you want to make predictions with will be. So you have to, this is just a case. This is a very, very simple case. And in the you can create to the model. URL in the sense that when you train a model, you can save the model in a format and in different kinds of like in sklearn, there are different ways to save your models. In TensorFlow, there are different ways to save it. Like I know in the previous session, I showed you guys how to save a TensorFlow model in a saved model format. So when you save that model, you are going to store that artifact. The standard name is artifact, but that model artifact somewhere. So KServe allows you to like save your model artifact on a cloud. this GS means Google storage. You can use S3, you can use Azure storage, and you can also host them on like any hosting platform like Google Drive and whatnot, Dropbox and others. So you just need to um and once I do that, because I've already done this before, it's it should be fast, but ideally it's going to take you some minutes before you get you get that's when you know that that's when you know that the service is up and running. But let me show you that this inference service also creates things like pod. Just that the inference service does everything for us under the hood. So if I do get pods, okay, sorry, this sklearn iris is going. So when you see that it's because and it created another one, like another pod. There are two ready and status ready, and it's terminating the old one because I've already done this before. And this is like the third time I'm doing it. That's why it's saying 003. And this is what K7 offers you version that and managing scaling and terminating of videos and other things like that. So let me check if the inference service is up now, and you can see that it says true. This is also the URL. This is used for us when you want to make a request to your model that is already running. So I think we will get that. So now we want to determine the ingress IP and port. So if you want to make a request to your is getting a service is to ingress gateway in the namespace is to your system. So Istio, like I said, is what takes care of the networking and the serving. I think the serverlessness of let's just say the networking of the K7 in system. So that's why we want to like look into like the service and see you're going to get something like the IP address, the port numbers are open and other information. So what this means now? So it's where you make a request to on K7, and we have the internal IP, then the internal IP, and now so you can see that external IP is pending. What this simply means is that is not deployed on a cloud platform that supports you have to that supports has external IP. I'm seeing a chat. Okay, my network is not stable. I'm sorry about it. I hope it's better. I hope it's better now. So the external IP means that I don't have an external IP that you can access this service over the internet. Because I'm working on just a local and prototyping and stuff like that. I don't have an external IP. But if you want to get an external IP, you have storage or build your own Kubernetes cluster and give it access to the internet. So these are the ports that are open for this service: port 1502180 and port 443. Wow, it's still saying my internet connection is unstable. All right, hopefully I won't get the network unstable. Okay, let's continue. So um now that we've done that, we can just go on to the next thing. Okay, I was explaining that the external IP, I don't have an external IP, so how do I access this model or this service? Wait. Okay, now to do that, service to to a port on my local BC, and it's connected to port 8080 on my own PC. So to do that, I just run this command, keep CTL port forward, issue system, and the service is still in ingress on that service, because remember that these are the ports that are open for this service, the three of them. So if I do that, we're going to have something running. It's going to be running on the back. Now the next thing to do is now to make a prediction, or make a prediction with this model. So to do that, I've already prepared like a script. I prepared a script that contains the the request.py that is also on the GitHub page there. So let me explain everything that is going on there. So remember, when I talked about the, the service, that I checked the service and we got this link. So how do you make a request now to this link? To make a request, you create the URL, and the URL, this and the ports, and the version, the model, and the model name. Then there is the to your KSEV model, and I think I will take you to where it is in the documentation. Model 7. Okay. Yeah, you can see that there's the /infra, and these are like different let's say services or different things that KSEF does for you. Can make you can inquire about the status of the model through the link. You can, it's if any of you have worked on like in the back end, you know that with you, if you work with fast API, you know that you can check the status of your model, the for now, since we just want to make a prediction, we are just going to use the underscore. These are just a few of what we have on KSEF. So this is the way to go. When you create the URL, you add something they call a header. Okay, I'm really sorry for my network. I don't know why it's glitching, but okay, let me continue from where I start. All right, so like I was explaining the URL. So I was saying the service host name means that we want to talk to this a specific model, a specific model. I remember to create the host name, you need a service And this is what actually changes this sklearn iris. So sklearn iris, the namespace, you know that a namespace can also mean like there are different projects. There are different projects that a company can be working on. One can be working on a computer vision project, one can be working on an NLP project. There are different teams. So what this namespace helps you do is that you can separate projects. You get, I know I just gave it the name KSF test because I'm just testing, but you can call this MNIST, MNIST vision. You can name it NLP, ChatGPT, stuff like that, depending on what project you're working on. So these are ways to like separate the the projects you're working on in the company, and also separate the models in the project. In a project, you can be training different kind of models to check out like which one is going to work better or best for this specific task you're trying to do, for instance. So these are what all these things mean. So the domain is where it gets tricky. Now I don't have a domain. And because I don't have a domain, I'm going to give you the example.com because it's just a simple example. I don't have an external IP. I'm not working on the cloud. This is just for prototyping and testing and understanding what goes on in case before carrying it to production. And and you have like a million requests with billion requests, depending on what's your on what model you're kind of you're exposing to the users. You get, so because I don't have a domain, it's going to be the example.com. But if you have a domain, like google.com, you pay for domains, you can now like add that into the URL, and you can make requests from anywhere. So now for this, like I was saying, this model is iris prediction. And I know every one of us knows what the iris data set and iris prediction data set is for. There are three classes: the setosa, iris versicolor, iris virginica, and there are like four input features. I think petal width, petal height, sepal width, sepal width, sepal height, I think. So that's what this was, like the petal width, petal height, sepal width, sepal height. And we're now trying to make a request to this model that is running now, that I put forwarded. So this is data. This is the format in which you make requests to a simple IS inference service running on the KSF cluster. So you make a request to the post request as usual. You add your JSON data and you add your headers here. So I now print out what the response I got from this model. So I can just run that if I do Python to it's in this case this case folder, I think test requests just py. Okay, now you can see that we got the prediction on 1.1. It means that there were two examples and there are two answers. So it's going to be 0, 1, 2. And so what 1 means is that I think these examples are iris versicolor. Let's check how it is in. See, yes, you see both sets of data points sent for inference correspond to flower index 1. And in this case, the model predicts that flowers are iris versicolor. So this is just like a very, very simple use case. Like for testing your KSF installation, there are a lot more things that can be done. I will show you just one with a TensorFlow model, and hopefully you guys can like do an exercise and will make it more interesting than it should be now. So for the next, I'll be talking about running a TensorFlow model on KSF. This was a scikit-learn model, and this time I want to make it more complicated by using a TensorFlow model. And so let's get into that. So the first thing is that I want to download this model. And I've already downloaded it actually. So what this model is This is a model that is hosted online. There are a lot of models online, but this one specifically was a model trained on the fashion data set. I think fashion MNIST data set. So what that means that is a data set of pictures of clothing, trousers, shirts, shoes, dresses. A very popular data set on online. And this was just a simple model trained on it, an exception V4 large model, and I just downloaded it. So after downloading it, um, let me go to where I downloaded it. So look at the model here, the exception V4 large. It's an H5 format. So remember I told you that we need our models in a saved model format. So to do that, I have to load the model again and save it in a saved model format. And I have the code for that. I've already run this in for, but I just want to show us the code that I use. So this converts.py, this converts, and I load that model. Then I now save it in the same model format in clothing model um um version 1. So I've already done that before, and it will take some time to redo it. So that's why I just want to skip that and like hope you guys understand what I just did. Like I said, I downloaded the model, the raw H5 A7 Kubernetes. You need your model in saved model format. So I have to load that H5 model, then save it again in saved model format. Now, since that's done, I I have the model in the clothing model. Remember where I saved it. So if I ls in one, these are all the assets. You can see the assets, the fingerprint, the PB. This is the way the save model format is. And um now that we have this, we can okay. So let me explain what's going on here in the next code. You have it in save model format. Now, KServe does something like mm, you can you can you can how will I put it? You can what's the word? You can compress your model further, you know, and compress your model and convert it to the towards TGS format. So what this means is that KServe will unpack this TGZ file and get the model and make the inference for us. Yet you know that the TGZ format will be it will be smaller, like lesser in size, and it just offers faster inference. That's just what it means. So since you have the saved model, you convert it. What all this code does is that it converts it's this star is a Linux folder into this file, and now we are now like zipping it into the TGZ file. Wow, my network again. Okay. Um, hopefully I don't disconnect again. So all right. So after doing all that, we can now host the file on my local machine. What this means, remember when I told you about this storing your model artifacts on Google Storage, you can because I'm testing here and I don't want to work with any cloud storage of any kind like S3 buckets, Google Cloud Storage. I just want to work on my local PC and have everything running for like test case. I'm now going to host it on my own PC itself. Like host, like you can with Python, you can create a server on your local PC, and that server can host like you host web pages, objects like files, models, stuff like that. So you can just like have a server running on your local, just this code. What this does, it just starts the a Python package called HTTP, starts the module server, and you have a website that's running on your local. You that work on like with backend and front end. Think you're familiar with this method. So now that I have this server running with my model being like hosted on this server, you can imagine this just being like an S3 bucket or Dropbox or Google Drive, and it's hosting this large what was it called? This large zipped model or saved model or TensorFlow model for us, and we want to use that model to make inference. I hope I'm like you understand what I'm saying here. So we are hosting this model now on a server, and we want to use this model now to create an inference service. So now to do that, I'm going to walk us through how to create our own. Okay, why is this not working? Sorry. Pardon. Okay. So I want to walk us through how to create our own YAML file for our own use case. So now I'm working with the TensorFlow model, like I said in my README. I'm trying to, before we use a simple SQL but now I want to use a TensorFlow model. Now I created a YAML called TensorFlow.yaml, and I'm using the 7. This is like a way to specify that this is K-serve you're working with, inference service. Now, the name of this inference service, I want to call it clothes because like I said, it's fashion needs data set. It was trained on pictures of different clothing, different clothes like trousers, pants, trousers, shoes, shirts, blouses. Yeah. So it was able to detect if this was a trouser, this was a shirt, and stuff like that. So now um I am going to specify like the predictor. Like I said, remember in the previous one, work with sklearn. Now I'm working with TensorFlow, and now storage URI. Storage URI, like I said, is I'm hosting I'm hosting the actual artifact. If I hope you guys understand what I'm saying. So where I'm hosting the actual model artifact that I want to load into this inference service. So like I said, because I'm hosting it on local, I'm just using a local IP address and port 8000. Like where is this server running is on port 800. So I'm just going to access the model there. And now resources, in the previous simple one, we did not specify like what resources we want to use, like because it's advisable that you specify the resources you want each of your model to use so that it doesn't exceed a specific limit and like crash your overall cluster. Yeah, because of the requests. Because Kubernetes does the auto scaling based on the request it gets and downscaling based on requests it gets. So we imagine like you didn't specify your memory you want each of the pods to use and services to use, and it just runs and it doesn't have a limit. It means that if you have like an 8 gig RAM system, whether you need to have more than that 32 gig, the number of pods will keep on increasing and stuff like overheating, and it just cause it to crash. Let me just say it like that. So it's good for you to specify what each pods should have, what memory they should use, what how much CPU they should use for each of the requests they get. So this is where this goes. You are telling that when you want to create it, this request means that when on creation, you should use 256 MB of RAM and half of your CPU. And the limit is that it should not go past 512 megabytes and one virtual CPU like for each request is handling, something like that. So um now that we have that, we can now create that inference service. Let me go back to it. So to do that, I just do kubectl apply this the YAML file. We can see the inference service 7 case codes created. So now let us get, remember I did not specify a namespace for this, so it's on in the general namespace. Okay, so it's still building up. Okay. Screen. All right. So if you see get before when I did QC get port, it told that there were no resources because it had not created the pods. So now we can see that now that the pods clothes predictor default 001 is running, which means now that the service should be running. Yes, you see, the service is running on this URL, this host, and it's ready for you to make predictions with the TensorFlow, with TensorFlow. And if you remember, you can see that you made a request. See, it gets artifact.tgz200 means that the request was okay. And so when the pod was created, it went to that URL to grab the artifact and it unzipped it, and it's all running on this pod here. It's a lot of things that KSAP does under the hood for us, so we don't need to worry about that. But that's the beauty of KSAP. You just need to host your model artifacts on cloud and create your YAML file, just one YAML file, and you have like a whole service running for your models, the ability to scale up and scale down. So now I want to make a request to this. Okay, let me close. Yeah. All right, I have to see port forward again because I can't access this model without port forward because there's no external IP, no domain and whatnot. So I have to port forward and access that model. Okay, and I'm port forwarding now, and if I want to make a request, I prepared a notebook for that just so I can explain what's going on. So this is the request package where you can use this package to make requests. Now, so I want to create the URL and the headers I'm going to use. Remember, service name. Remember the namespace. I told you I used the default namespace. I didn't specify a namespace when I was creating this port. So what that means is that if you don't specify a namespace when you're creating your service, whatever your pod, your inference service, it's going to create everything on the default namespace, which is okay if it is not. All right, this is breaking. I'm really sorry, guys. I'm really, really sorry. So okay, so what's the like I was explaining, the default means that I didn't specify a namespace when I was creating this port, and I don't have a domain, so I'm using the example.com, which is what SketchUp offers like on default. So and I'm hosting this model on my local PC, and I want to make a request now. So now what this Keras image helps us do is that you know that you have an image. Yeah, you have an image. And when you were building a model, you did pre-processing on that image. And there are specific processing you do for specific models, because if you train your model with like pixel value 720 by 720, and you want to make a inference with images of 1024p, it won't work because that's not how you train your model. So what this create processor does is that it helps us create process whatever image you give it to the format that is acceptable for this version exception. Remember that when I downloaded the model, it was exception v4. So what this is doing is a helper function that helps us processing for us to the right format. So I'm going to load that, and now I'm going to get a test image. So if I go to this link, I want to show you like what image I'm using for prediction. Now you can see the image now is actually the image of a pant, of a trouser, whatever pants, trousers, depending on what country you are. And so this is the image I'm working with now to make inference on this TensorFlow model that is running. And so I'm going to go to that site and run the processing on that image. It's going to download the image and do the processing for us. So now I check the shape of that image. It's 29 by 29 by 3 channels of an image. One means that you need your 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 data to be in a 4D tensor, because that's how you train your model. You get, so it's under the head what goes on in TensorFlow. So now to make a request, remember when we made the request to the sklearn model, you put it in a JSON, then you specify instances. This is where you make a list of all the examples you want to make, like also all the predictions you want to make. So x.list means that, I think I explained it in last class. JSON doesn't understand what NumPy array is or TensorFlow array is or whatever those are. You just understand simple arrays, and that's why we're converting it to lists. List is like the standard array that JSON requests understand, or many requests. Like it's just like I don't know how to explain it, like in depth, but just know that it doesn't accept NumPy arrays, JSONs. They don't work with NumPy. You get an error if you just put in X here. So you have to convert it to the formats that you understand. So this is lists. So if I do that, I have my request now. And if I show you what the request is, you will see that it's a very long um like list of values. These are pixel values from 0 to 25. They've been normalized. I think this is in standard normalization, because that's negative. Min max is from 0 to 1. I think the standard norm is from -1 to 1. So that's what it did. And now I want to make a request to that specific link. So I'm not going to print the predictions. No, I'm going to print predictions for us to see what it gives. You can see that there's a list. Now we don't understand what this means. I'm just getting, and these are probabilities actually. Probabilities of what, like, you don't understand what all these values mean. So this is when we now do the I want to make you understand. These are the classes. Like I said, the fashion MNIST data set, we have dresses, hats, long sleeve, outerwear, pants, shirts, shoes, short skirts, and t-shirts. So this is what all these values means in this list. So I want to like put in a format that you understand. So classes, I'm going to select the first row, because this is a 1 by 2 array, or a 2 by 1. No, it's not. It's I think a 1 by 10 array, 1 by 10. So you just want to select the first row, which is just spread. You see that just gives us one list now. And you have that now. Now we see that actually the one with the highest probability was pants. And if you remember the image I showed you, then you see that this was actually a picture of a pants. So was able to classify that this is a pant, and it classified with a very, very high accuracy. Okay, so I think I've like covered what I wanted for today, but I want to like give like a heads, like an assignment or something like that for you guys to practice on your own. So now there's a way with KSAF, you know that when you're actually making requests, or when the model is exposed to users, the users don't have access to that long list of integers and this. What they actually have is a list, is a link or image file, and they just want to give you the image or the link to the image, and they want you to do all the pre-processing for them. Yeah. And do the pre-processing and post-processing, because if you gave them an output like this, they don't really understand what this is. So they want the outputs to be something like this, or just even this. So now how do we do that? Now, this is like an assignment for us, or um, there's something they call the transformer. I didn't specify it in this one, but what it means is that there is now another container that does the pre-processing and post-processing for us. Pre-processing as in it converts the image, the raw image you give it, into those list of integers. And the post-processing is this: when you convert this prediction numbers that it gives you, you get, or just submit, just show pants. That's what he predicted. If you get what I mean. So it's like there's an extra thing we need to do for us to have all this in our inference service. And I've given like an overview of how to do that here. Deploy transformer with inference service. So what it does is that it does the pre-processing and post-processing for us on whatever request we make, and gives us prediction in a readable format. So it's just like embodies like what KServe offers. It offers a lot. So if you remember the picture I showed us, you see that you see the pre-processing, the prediction. Those transformers is what does this pre-processing and the post-processing for us. And it's a very handy tool if you want to host it on actual website for users. So I think I'll call it a day for today. I don't know if there are any questions. If there are any questions, please feel free to ask. Are there any questions? Okay, so if there are no questions, I think I'll call it a day. And good luck, like in terms on your next track. All right.